we take a look at question 15 through 19 here, we want to determine if these are sometimes, always, or never can be inscribed in a circle. Remember the whole idea of if you have a quadrilateral inscribed in a circle, we know that the opposite angles have to be supplementary. So does the square have opposite angles supplementary? It always does, doesn't it? How about a rectangle? Once again, always. A parallelogram? Well, no, not just any parallelogram, but if it was a rectangle or a square it would be, so that would be sometimes. The same thing, a rhombus would be sometimes if it's a square. A kite, it could be if the opposite angles are supplementary. There's nothing preventing them from being supplementary, but they don't have to be, so that'd be sometimes. And then on number 20, we have a square. It's inscribed in a circle. Now, I might not have drawn the square the best, but we'll go with that. What's the ratio of the area of the circle, pi r squared, to the area of the square, which is side squared? And to find the area of a circle, we need to know the radius. So I've got this square. In fact, I've got you see that? We've got a special right triangle here. It's a 45, 45, 90 triangle. So I know my diameter is going to be x times the square root of 2. Now, to find the area, my radius then would be x times the square root of 2 divided by 2. So the area of my circle is going to be pi times x times the square root of 2 divided by 2 squared. Pi r squared. So that would be x squared times 2 divided by 4, because 2 squared is 4. The 2's reduce, 2 goes into 4 twice, so I get x squared divided by 2. Now the area of the square, that's just going to be plain old x squared, isn't it? So then I'm going to take x squared over 2 divided by x squared. My x squareds reduce. And I would get 1 over 2, wouldn't I? That's kind of weird. Oh, I forgot my pi, didn't I? Times pi. So it would be pi over 2. That makes more sense. I'm going, what happened to my pi? Okay. Number 21, a 45, 45, 90 right triangle is inscribed in a circle. So let's draw that out. If the radius of the circle is given, explain how to find the lengths of the right triangle. Oh, because I would know that since it's a right triangle, I know this is the semicircle, so this is my diameter, isn't it? And then to find the length, I divide by the square root of 2. So it would be d divided by the square root of 2. But we don't like square root of 2 in the denominator. So to find the length of each side, it'll be d times the square root of 2 over 2. And there we have it. I guess I should say, since I'm doing an r, maybe I should say 2r square roots of 2 over 2, or it'd be r times the square root of 2. Either way would be correct.